Let's now talk about something else, characters. We have been mainly concerned with digits up to now, but there are certain programs in this problem sheet where you have to handle characters. Now, these are quite advanced programs. In fact, these two are really quite advanced programs. These are taken from the original C book by Cunningham and Ritchie. So interesting programs. And if you have previous knowledge of strings, how to handle strings, arrays, as well as iterations, you can try out these two programs. In our class, right now, I'll not be covering these two. Maybe towards the end, when we have learned sufficient amount of background knowledge and theory about these things, we will be coming back to it. But simple characters we can handle now, and we know that these are initialized as follows with this keyword char followed by a variable name. So example would be like this or something like this. Okay. So here, simply define character. We'll take input of character. The type specifier here is %C. Store it in this variable. Let's do this type %C %B. What do you think should happen here? Any ideas? I have entered a character. Now, I want to print that character. So I have used %C here, but I have also used %D. What is this going to do? Let's see. The character that I want is, let's say, capital A. You can see that capital A has been printed. Here there is capital A, but beside that there is a number, integer number 65. So is that a garbage value? What is happening here?
It's a ASCII number.
This is the ASCII number. Every character is associated with an integer value, and that is called its ASCII code or ASCII value. If you go for small a, you'll see that that value comes out to be 97. So all the characters that are used in C have their own ASCII codes. So we have, this is ASCII codes. What is the full form of this? American Standard Code for Information Interchange. So that is what is the short form, gives us ASCII. So any character, this modulus character or the enter, sorry, not enter, the tab, not this one. Or backslash, or characters, printable characters such as A, B, C, or capital A, capital B, like that, or even these digits, they are associated with these codes. We have an ASCII table that is given here. You can see this American Standard Code for Information Interchange. That is the ASCII character codes. So how do we read these codes? Let me just minimize this just a little bit so that you can see the entire table. So this is the entire table. So there are two sets of numbers starting with 0. This goes down like this along the rows, and these are the column headings. So for capital A, you have 6 and there is 5. So 65. The ASCII code for A is 65. Similarly, for B, it is 66. C is 67. Like that, it will continue. And they are continuous. A, B, C, like that, up to capital Z. Similarly, you can see that the small a has 9 here and 7 here. So the ASCII code for small a, lowercase a, is 97. For B, it is 98. And like that, it will continue. What about the digits? The digits are here. So this is 4. This is 8. 0 has an ASCII code of 48. So every character, the parenthesis, the plus sign, comma, slash and backslash, exclamation mark. So these are all printable characters. Even the non-printing characters, they also have ASCII codes. So that is what is being shown here. Let's take another example. Let's say I want the modulus character. I have written the modulus character. This shows up as 37. Let's check. So this is the modulus character right over here. So we have 3 and 7. So that is quite correct. Ampersand would be 38. So this is the ASCII character table, and you should be aware of what are certain ASCII values, but that is not critical. Means you do not have to memorize that entire table. That table is quite easily available, and while doing programs, if you need it, then you can refer to that table. So there was a program here that says this: we are going to encode a 5-letter word using certain algorithm. Basic encryption of subtracting 30, I think. Letter A, which is represented by 97. That means this is the ASCII value. It becomes capital C, represented by 67. And how we do that? On a letter by letter basis, we are subtracting 30 from the ASCII value. So how can we do this program? This one, I'm not going to write it out. I have already got a version of this program with me here. I have already written it, so I'll show you. So here we start with an integer variable, int I equal to 0. And then we have this declaration. Now this might seem just a little bit odd to you because we have not yet studied about arrays. Now arrays are a type of variable, a special type of variable that can store multiple values of same nature. Let me just go back here. Now, what is an array? Of course, we'll read about arrays in much more detail in 2 or 3 classes. But right now, you just understand that it's a variable that stores multiple values of same kind, same type. A visual representation of an array would be something like this. So in the computer memory, such a space is allocated for an array, and these places can be accessed using the array index. Let's say we have got an array by the name marks. I'm going to store marks in this. So it is going to be initialized as, let's say, float marks. There are 16 students here, so put 16. So the size of the array is 16. So it starts from 1, sorry, it starts from 0 actually. Then it's 1, 2, like that. It will go up to 50. Individual values can be stored in these places. So that is how they are defined, initialized. Now suppose I want the marks of the student whose roll number is 10. So I have to access this. How we can access this? I'll just simply write marks, and then within the bracket, I'll write 10. So that gives me the value which is stored here. So that is the gist of what arrays are. Now, in continuation to this, you will also have to know about strings. What are strings? Again, this topic will be covered in much more detail in a later class. So in C program, a string is a sequence of characters. And this sequence of characters would be terminated with a null character. Null character is usually represented like this. So basically a string would be, sorry, let's say A, B, C, E, E, and then there's this null character. This actually signifies end of the string. So with that basic knowledge, you don't have to go too much into the depth right now. I will cover it in a later class. Both arrays will be covered and strings will also be covered. But right now, I'll just show you what we can do with the help of, say, characters and strings. An example of a simple program. So this is the printf command. Enter a 5-letter word. I'm taking input. So scanf %s. Note the type specifier. This is %s. That indicates that it is going to be a string. And it is going to be stored in text 1. So you can print it out and say that the following word is entered. And then what we do is we do this text 1 at the 0th place, the first digit. From that, I'm subtracting 10. And the second one, sorry, I'm subtracting 30. And from the second one, also subtracting 30. Like that, from all of these values, I'm subtracting 30. Why does this work? This works because in C, even if I'm writing a character, that will be stored in terms of its ASCII code. So from that ASCII code, 30 is taken out. So if this was 97, becomes 67. 97 is small a, 67 is capital C. In terms of the table, 67 is capital C. 97 is small a. So character wise, each of these letters would be encoded. Sorry, not audible. I can't get what you are saying. But let me run this.
I was telling that we are performing a basic type of encryption.
Yes, this is encryption. Until and unless you know the key to that encryption, that means you have taken out 30 from each of these numbers, you would be at a loss. What is happening? Just write anything. Let's write Okay, A, B, C, D, E. Fine. 5-letter word. And you can see that the encoded word is C, capital D, and caps E, F, and G. So if you do not know that how this character string has been created, you would not have any idea what this original string was. Okay. So you can see that in here, within the commented section, there's a more general program, more generalized program. And that maybe also I'll be able to show you. Yeah, that's there. In case of strings, we can use certain library functions, just like we use scanf to get the input of strings. We can use fgets. To write it, we can use puts or put string. Previously, in earlier versions of C, you might have come across gets, but that is now taken out of the standard C, that is standard library. So if you use get you might get an warning. So don't use that. The problem with this, that is using scanf, is that as soon as you put a space, it doesn't work anymore. So everything that is there before the space will be taken as input. Anything after the space would not be taken as input. Let me just show you, not in this program, maybe I can copy it out. Open a new file, not appending the previous documentations, but obviously I'll need to use the thinking hash include part is not required. Get rid of it. That is also not required. So we'll save this first of all. If I write my name, or let's say A, even though this is not 5 letters. So following word is entered, only A. Why? Because I have put a space here. So if you want to encode a line, this doesn't work. What you have to do is go for this fget s, that library function. So we enter a line of text, and then we'll see what happens. If I enter this, then you can see the following line is entered. and the entire thing has come out here. Now, if we come here and we have used a generalized program here. Again, while function would be introduced to you probably in the next class, and then you'll be able to better appreciate the finesse of this these lines of codes. But the general principle remains the same. The algorithm is the same thing, that for each of these letters, or even you can say from each of these characters, from their ASCII codes, 30 has been taken. So this is just one type of encoding, simple encoding. You may also use other values or variable values here, but those are not within the purview of this class, and we'll skip that for a moment. But I can definitely show you one example is so that is the entered line, and this is the encoded line. So obviously you won't have any idea what has been written here until and unless you have the decoding program, which will of course take up this input, this line as input, add 30 to it, and then reconvert it back to something legible. So just to point out here, fgets uses the name, variable name, where it is going to be stored, the size of that variable space, the space allocated for it. Obviously, you can see that here 100 places have been reserved. So that is used. And from where this input is going to be taken. So standard input is from the keyboard. So it takes it from the keyboard. So these are certain examples of programs. Not all of them are obviously simple. Difficult programs have also been shown in today's class. But I just wanted to make it clear what is the scope of this programming language. It has got a huge scope. You can do so many unique things with this coding. And I just hope that you pursue it with all your attention. You should give it some time. It's a very interesting subject. Learn about it. If you have difficulties, then of course you can come to me with your questions and we'll try to discuss it. So that's all for today's class.